Okay, after understanding what is rational numbers, we could move into the second part, which is called as irrational numbers. Now, what are irrational numbers? As I have already written here, the irrational numbers are the numbers which you cannot write them in p by q form. So, but you can say that all the numbers that are existing can be written in p by q form, isn't it? We took into consideration in the rational numbers part. Natural numbers are rational, whole numbers are rational, integers are rational, zero is also a rational number, decimal numbers are all rationals, isn't it? All of these are rational numbers. Then what is it that which is an irrational number? So the numbers under root, these are considered to be irrational numbers. So if I say root 2 is there, then it is irrational, because when I simplify this, its value is going to be very long decimal value is what I'm going to get in here. Okay, so I'm not bothered about what value I am going to get, but I'm just bothered that it is a number under root which is not a perfect square. So if I take into consideration root 3, again it is irrational. But what about root 4? Root 4, its direct answer is plus or minus 2, isn't it? Its direct answer is plus or minus 2. So people may say, how plus or minus 2? So take into consideration plus 2 times of plus 2 if I'm writing under the root. Okay, so what is it going to be? It's actually root 4, right? Root 4 can be written as plus 2 times of plus 2. This is plus 2 is one term, plus 2 is one term, they multiply, it is equal to root 4. Root 4 can also be written as minus 2 times of minus 2. Okay, minus into minus, it becomes plus. 2 into 2, 4. So whether it is plus or minus, its answer is going to be plus or minus of 2. Root 4 is a perfect square number, so its answer is going to be directly 2. I don't need to solve it, and it's not going to be a decimal long answer that I'm going to get in here. So it's going to be a very small answer, that is, and directly I will get its value. So this is not irrational, but these two are irrational. So if I write down root 2, root 3, root 5, root 6, root 7, root 8, root 10. Again, I have skipped root 9 because root 9 can be written as plus or minus of 3. So here root 4 is plus or minus of 2. Likewise, root 9 is plus or minus of 3. This is how we understand that we cannot write. What can we not do? We cannot write the numbers under root in the form of you cannot represent them on a rational number scale. Okay, so rational numbers, if I'm drawing rational numbers on the scale, I can actually draw 1, 0, 1, 2, 3, 4, 5, 6. But what about these are the rational numbers that I'm plotting on the scale. I am drawing a number line and I am plotting on it. Okay, but what about the irrational numbers? Okay, I have a 0, I have a 1, I have a 2, but where exactly will root 2 come? Root 2 value is something 1.4 something, it is there. So considering this particular value, root 2 is 1.4 something something something, and root 3 is 1.7 something something something. It's a very big value. It's not exactly like 1.7. If 1.7, I can make 1, 2, 3, 4, 5, 6, 7, 8, 9, and I can point root 2 would come at 1, 2, 3, 4. Root 2 would be here, okay, and root 3 would come at 1.7. So it would be somewhere here. This would be root 3. But this is not exactly what the values are. The values for root 3 is actually 1.73205 something karke it is. Okay. And going to the value of your root 2, it is 1.1421 something something. So how am I going to know exactly it is 1.14? So in between this there are furthermore divisions, so I cannot actually draw like how am I cannot mark them on the number line. So one more thing that you get to know is irrational numbers cannot be marked on the number line. These are the irrational numbers and it cannot be marked on the number line. Another type of an irrational number is pi. Okay, pi is considered to be an irrational number because its value is 3.147 so on and on. So pi is also considered to be an irrational number in here. Let's go with the exercise questions, okay, or move to the textbook back again. And now this is in this particular part we are going to plot, okay, we are going to plot or mark the irrational numbers. Okay, we are going to mark irrational numbers. Numbers on the number line. Okay, what are we going to do? We are going to plot or mark the irrational numbers on a number line. So what is the first irrational number? People would say root 1. Root 1 value is 1 only, because 1 times 1 is 1, minus 1 times minus 1 is also 1. So it is also 1 is a rational number. So the first irrational number that you have is root 2. First irrational number that you have is root 2. This is the first one. Okay, just note it down somewhere. And last irrational number can be under root of infinite number. Okay, it can be any number, infinite number, it can be anything, because numbers are continuing. So last number is not known to us, it is root of infinity. Okay, first one is root of 2 is the first irrational number that we have. Now since this is the first irrational number, we are going to mark it on the number line now. And that process I'll do it on a plain sheet of paper so that it's very clearly visible to us. So I have here root 2 that has to be marked on the number line. So for that, what I'm drawing is I am drawing a line. Okay, a small line would be enough. Just mark your values, because this root 2 is a positive number. So what we are going to do is we are going to start marking from 0, and this distance that you're going to take is, how am I going to get root 2? First of all, let's take into consideration that particular thing. Okay, before I start with the things, everything, the marking, we'll understand how we can get the value of root 2. We are here using the Pythagoras theorem. What theorem we are using? Pythagoras theorem is what we are using here. Okay, what happens in a Pythagoras theorem? Let's see in here. Okay, a Pythagoras theorem mein we usually consider right angled triangles, or right triangled triangles, or right triangles is what we are going to consider. Suppose what I am doing is 1 centimeter sleeping line, 1 centimeter standing line. Okay, then what will this, to make it a right angle triangle, I need to join this, isn't it? I had 1 centimeter here, 1 centimeter here, and to make it a right angle triangle, I had to join this. And this you already know, here is a right angle triangle, right angle. So this side will be called as hypotenuse, isn't it? It will be called as hypotenuse, isn't it? So this hypotenuse ka value, how do you get? By the Pythagoras theorem. The sum, what does the Pythagoras theorem says? Write it down. Sum of square. First sum them. Sum of what? Squares. Okay, is equal to square, sum of square of sides is equal to hypotenuse square. Okay, is equal to the hypotenuse square is the thing that we are understanding here. So coming again, how are we marking the irrational numbers? To mark irrational numbers, when I need to mark on it, how am I going to do it? I am going to take down the number, and what is it actually? It is going to be written as root of 1 plus 1. Okay, so it can be written as root 1 plus root 1, which is nothing but 1 plus 1 itself. Okay, because root 1 ka answer we just told that root 1 is equal to 1 itself. So 1 plus 1. So we are breaking the number under root. First of all, we are breaking the number under the root in simpler fashion. So 2 ko we know it can be written as 1 and 1. So root 1 plus root 1, it becomes 1 plus 1 individually. Okay, so how are we going? We are doing with the Pythagoras theorem. Okay, Pythagoras theorem. Now what does it say? It deals with the right angle triangle, and what are the dimensions? Now I'm drawing the right angle triangle, and what can be the dimensions of that right angle triangle? It is 1 centimeter, 1 centimeter. So 1 centimeter, 1 centimeter. What does the Pythagoras theorem say? It says that the sum करना है, okay, किसका? Of square. सम करेंगे इन दोनों के स्क्वायर्स का. What are these? Of sides is equal to hypotenuse square is equal to hypotenuse square. But अब मुझे यहाँ पे okay, so this is what it is saying. But I just want the hypotenuse. I just want to have the hypotenuse. I don't want hypotenuse square. So what I'm going to do, I'm going to send the square towards the other side. It becomes root of 1 square plus 1 square. That is nothing but the hypotenuse. 1 square plus 1 square becomes hypotenuse. Understand? This is what we are going to get in here. Okay, 1 square plus 1 square is the hypotenuse is what we have here. Okay, cool. So 1 square plus 1 square is 1, 1 square is 1, root is there already, it becomes root 2. So the hypotenuse length that you're getting is root 2. So when I'm marking 1 centimeter here, 1 centimeter, 1 centimeter here, and I'm marking 1 centimeter here, and I am joining these 2 points, this length that I'm going to get will be root 2 centimeter. Sorry, root 2 will be the value of it. Okay, what its value will be? It will be root 2. Okay, now this is how I get the length of root 2. मुझे exactly root 2 की length मिल गई. Okay, that's what we are going to do on the paper now. So to mark root 2 on the number line, we have drawn a line, we marked a 0. Okay, drew a line, marked a 0. From here, measure 1 centimeters. Okay, from here, I'm putting it here. Okay, and I'm marking my 1 centimeters here. Okay, 1 centimeter here. Likewise, we'll mark a few more, 2 and 3. I'm going up to 1, 2 and 3. So I'll write it down here. 1 centimeter, 2 centimeter, 3 centimeter. So this distance is already 1 centimeter, I know. Okay, now then what am I going to do? I am going to, from here, this part is done now. This part is done. Then I have to mark this 1 centimeter. So what I'm going to do, if children are very quick, what they can do is they can use this to mark 90-degree angle, isn't it? How do you mark the 90-degree angle? From here, measure 1 centimeter. From here, measure 1 centimeter and draw the arcs. Sorry, draw the arc from here. Draw the arc from here and draw another arc from here. So you get a point. Can you see that you got a point here? Sorry, 1 minute. You got a point to join this. Okay, you can just use that and draw it. But most of the time, children will not be perfect with this. So what you can do is you can use a set squares. Let me just show you with set square. So now we're not going to use this. Instead, we are going to take a few things that are present in our geometry box and which look like these triangles and all, and we're going to use them here. Okay, now the set square that I told you, these are the set squares that you have actually. Okay, and this one is a 90-degree set square. This one that you can see, if you put it like this on a piece of paper, you can see that it is actually making a straight line. But whereas if you put this one in here, this is not making a right angle triangle. They both make right angle triangles actually, but this is an elongated one, this is an isosceles, and this is an isosceles, this is a scalene triangle that you have. Okay, this is scalene, all the 3 sides are different, scalene, and this is isosceles. Any one of these you take and you can measure and mark 1 centimeter. Okay, that is very much easier for you to do it. Okay, so let me just do it here. I am placing it such that the 1 centimeter comes in here for me, and then I can mark my another 1 centimeter, the vertical or the standing 1 centimeter line that I have to draw. I can draw that here, so I get the point. So now here I'm doing it with one hand, so you can do it with 2 hands and you can do it here. Okay, on this particular point I'm getting the thing. Okay, so this distance that I am getting here, this distance is nothing but the 1 centimeter distance that I have here. Okay, this is the 1 centimeter. Use a scale to mark them down. Okay, so I can write here this is 1 centimeter, and so also this is 1 centimeter. Now if I join these two, if I'm joining these two, what is happening? This is nothing but my root 2. Okay, but I want to plot it down now. So how am I going to plot it down? To plot this particular thing down, take your what do you say, your protractor, sorry, compass. I am so bad. Okay, take your compass, measure from the 0, measure the root 2, this is the measure of the root 2, and drop it down. And what we are going to do, we are going to drop it down. Okay, so here, this particular point that I got here, this is going to be my root 2 point on this particular number line that I have here. Okay, so let's do it once again so that we understand it very much well and clear. Okay, so what we are going to do again here, I am plotting a root 2 value again on the number line. What am I plotting? Root 2 value again I'm plotting. Okay, now people would say, why not directly go for root 3? We can go for root 3 later, but let's first understand, because this is a basic one, we'll understand it. So root 2, I am splitting it as root 1 plus root 1. Okay, I get it, but I'm squaring them both. Okay, I'm squaring them both, so 1 square plus 1 square is happening in here for applying the Pythagoras theorem in here. Okay, so when I'm doing this, so I know that I have to draw 1 centimeter horizontally, 1 centimeter vertically, then join them, put the compass needle here, measure this and drop it down. This is what is going to be my root 2. Okay, so that's exactly what we are going to do again over here. Okay, taking my scale, drawing the number line that I get here. Once after drawing the number line, marking my 0, and I need to mark my 1, 2, 3. So with the same scale, if I can, I'll take it and start marking my 1, 2 and 3. Okay, so here is my 1 centimeter, it completes, 2 centimeter completes here, and my 3 centimeter completes in here. Okay, so marking them as 1, 2 and 3 centimeters. Now what I'm going to do, I need to again mark another 90 degree ka centimeter. So using this or using this, you can do it. Some want to do it like this, go ahead and do it. So but your point, you will get somewhere very high. Okay, this is the point where I'm getting my 90 degrees here. Okay, but if I'm using this, I can actually mark my 90 degrees very easily using this. Okay, just placing it along with the line. Now here, if you can see, my placement is very accurate with the line. Okay, so that I exactly get my 1 centimeter ka point. This length will be 1 centimeter in here. Okay, this length is 1 centimeter in here. So once after I get the 1 centimeter, I am going to use the same line, same scale or whatever you are using to mark it. Okay, now students at times, what they'll do is they will not mark this point. Okay, they'll not mark this point, or what they'll do is, they'll think, they can do it with the scale. No, with the scale, sometimes if I'm measuring it wrong, sometimes, look, for me it appears to be 90 degrees exactly here. Okay, मुझे अभी के लिए ऐसा दिखाई दे रहा है, it is 90 degrees, but it is a little bit moved from 90 degrees. There's a difference between this point and the scale where it is coming. So if I'm marking 1 centimeter like this, it is going to be difficult. That is the reason, either go with this or go with this to mark your perpendicular lines. Okay, now let me just use this and mark it here, join the lines. Okay, I have joined the line now. So this is 1 centimeter that I have got, and this is my 1 centimeter that I have here. Then I'm going to join these both. Okay, I have joined this. Now this dimension will be root 2. So for me to mark it down on the number line, what I'm going to do, I'm going to place it on the 0, measure this root 2 ka distance. Okay, this is root 2 measured, and I am going to drop it down, and I am going to drop it down. So this point at which this has come, this is my root 2. So I am going to write here root 2 units karke I'm going to write it down here. Okay,